Okay, so the next section we're going to talk about are angles and their measures. Okay, so an angle is going to be a figure that consists of two rays connected together, and where they connect is going to be called the vertex. Okay, so each ray is one of the sides of the angle, and the vertex right here is where they connect. Now, we can name angles in a couple different ways. So for this angle, because it's by itself, we can just name it angle A, and we're going to be using the vertex to come up with that name. So angle A came from the fact that A is the vertex. However, sometimes we're going to have multiple angles together in the same figure, and you won't be able to determine which one is angle A because there might be multiple ones that have that same vertex. So we're also going to, if necessary, name an angle by a point, its vertex, and the other point. Okay, imperative that the vertex is in the middle here. So notice it can be called BAC or CAB, but the A is always in the middle. So when we're naming an angle, we're going to make sure that we name it using either just the one letter of its vertex if it's by itself, or we can name it using the three different points with the vertex in the middle. Okay, so for instance, if I wanted to name this smaller angle here, notice that it has vertex Q, but so do all the other angles. So for this one, I'm going to have to name this angle PQS or SQP. If I then wanted to look at the smaller angle, I'm sorry, not the smaller, the other small angle, okay, right here, again, I have that same vertex, and so again, I need three letters to name that one, so I would name it SQR or RQS. Then if I want to name the larger angle that's on the outside here, I would have to name this either PQR or RQP. Okay, so again, I just need to name all of these angles using three letters because they are attached. So if I simply said angle Q, you wouldn't know which angle I was referring to. All right, so we're going to work with protractors more in class. So we're going to skip this section for now, and we'll do the actual protractor work during class. As we talked about congruent segments earlier, okay, we also are going to have congruent angles. So if angles have the same measure, they're going to be considered congruent. And again, that's going to be something that we'll see throughout. We're going to have congruent segments, congruent angles, congruent figures. Congruent just meaning that the measures are equal. And same thing that we talked about when it came to segments was that when we're talking about the measure, meaning the angle, say 50 degrees or 60 degrees, we're going to be saying the measure of the angle. So we use this little m in front to show that we're talking about a value. And then we're going to use an equal sign to show, again, that we're talking about the value. So I could say measure of angle BAC equals 50 degrees, or I can say measure of angle BAC equals measure of angle DEF. However, if I'm talking about, and that would be, again, talking about the values, the number attached to that angle. If I'm talking about the physical angle itself, I'm talking about the figure, now I'm going to say the angles are congruent. So again, now we drop the M in front because we're not talking about a measurement, we're talking about the angle itself. And we're going to use a congruent symbol versus the equal sign. And again, we'll get to protractors in class. Okay, talking about the interior and exterior of angles is pretty self-explanatory. Interior will be on the inside, okay, or in between the two rays, and exterior will be on the outside, or outside of those two rays. Our angle addition postulate is very similar to our segment addition postulate that we had spoken about, which just says the two pieces of the angle equal the whole thing. So again, for instance, if I had the measure of this angle was 35 degrees, and the measure of this angle were 60 degrees, then I could say the whole thing together was 95. Or vice versa, if I told you the whole measure was, say, 80 degrees, and I told you this piece was 30, you could then assume that this piece would be 50. Okay, so very simple, very similar to the segment addition postulate. Classifying angles, I'm sure most of this you have seen before. Acute being less than 90, right being equal to 90, obtuse being greater than 90, and straight being exactly 180 degrees. Okay, adjacent. when we talk about adjacent angles, think about what the word adjacent means in real life. So for instance, you may say my classroom is adjacent to Mrs. Beaton's classroom because we share that wall. So when we talk about adjacent angles, we're going to talk about angles that share a ray. Now what's important is that they don't overlap either. So for instance, if I drew this, okay, I could say the angle ABC and CBD are adjacent angles. However, if I drew something like this, call this X, Y, Z, W, U. I couldn't say that X, U, Z and Y, U, W are adjacent because they would be overlapping everywhere in here. Okay, so adjacent means they're going to share a vertex and a side, but they're not going to overlap at all. And now we have some practice examples. So for my acute angle, again, being less than 90 would be this one. Obtuse, being greater than, would be right here. Right, being exactly 90 degrees, would be here. And straight will be the one that is exactly 180. Okay. Now, to look at these practice examples, it asks us angle DEF congruent to angle FEG. Okay, remember that, again, I know that they're talking about congruence because of this symbol right here. And congruent meaning same measure. These are each 45 degrees, so I could say yes. Angle DEG, so 245, so that would equal 90. And angle HEG, okay, so that's also equal 90. So again, I can say yes, these are congruent as well. For 7, DEF and FEH, are they adjacent? So let's look, DEF and FEH. Okay, those two angles share a common endpoint. They